Okay, let's try to start. If some student miss it, hopefully it records well, so they get the recording. So last week, you guys left off with HTML, CSS, and some DOM manipulation, right? And now we're trying to move away from that and learn more of the JavaScript and hopefully learn why TypeScript is very important. So let's start ahead with where you guys left off. So you do a doc type HTML. It just directs the browser that says, oh, I want you to use the HTML5 in the browsers. And oh, hey there. You can just stop video or you can just keep your face there. It's like you're the instructor. So you now put an HTML tag so the browser would know, hey, it's an HTML5, okay? Put a head tag where you usually put the metadata, title, and scripts. Body, where you put, let's say, your message. Hello, CS142. And in the head, let's put a script there. So this gives you an idea that JavaScript is a scripting language. So let's do a simple one. And put a semicolon. And we can just run this in the browser. See, and it says over there, hello, hello, CS152. Okay. Going back, how do I go back there? So alert, okay, we use this alert API so that the browser would alert or prompt the user a message or sometimes an input. Another API that's commonly used is the CONSOLE.LOG. It means that, hey, log this out to the console of the browser. So we can try that again. Browser. This time around, you right-click your browser, hit inspect, and I'll try to zoom this in. Okay, there you go. Hello, CS142. Okay, going back. Now let's try assigning some variables. Var is a keyword in JavaScript where you can declare some variables and give it a variable name. Let's say A, and then put a string. Let's say hello class. And then now we pass that variable to as a parameter to console.log. Let's see that again. Inspect. Should see hello class at the bottom. This one. Okay. Another way that we can use is let. Basically, var and let just differs. Var is saying global, and let is just saying limit me to my scope. So this will also generate the same output. However, if we put const, it also is limited to the scope, and you can't reassign a value to that. So I wanted to change it to hey there, and let's see. To the browser again. Inspect. Now you see an error. This at the bottom, it says uncaught type error, assignment to the file name and code line, and then it says constant variable. So now what you're seeing is you're putting code in your file, but there's no way to check it before running it. So usually things go kaput in after you run it, meaning in the browser. So let's try to now separate this because usually it's good to put them in a separate file. So let me put that, say, in another JavaScript file. And let's try to link that. Source, JS, and let's just see that it should still have the same one. In browser, Inspect. Still have the same output. So now we're moving away to this browser, and next time around, we're just gonna focus on using JavaScript files and TypeScript files, okay? So let's go ahead and open the PowerPoint, and we'll go back to the editor, okay? Let's see. If you have any questions anytime, do ask, and I'll try to answer if I can or not. I have Google here. Uh-huh. Go ahead. Okay, so basically in the browser, there's HTML, which is your markup language. CSS is your styling. And JavaScript, you put like scripts and program there so that you can make dynamic apps in the browser. And basically with JavaScript, you don't really need to have your own runtime because you just put it in the browser and the browser run it with V8 engine, which is the Chrome, okay? So if you're a web developer using any stack, you can't really like say, oh, I want HTML, CSS, and no JavaScript. You can't do that because everything in the front end uses JavaScript. Unless you have another scripting language that, let's say, it's a framework for JavaScript. Let's say CoffeeScript. CoffeeScript is like, gives you a way so that you can easily program in JavaScript, but again, it looks different. Mm-hmm. Web page? Sure. So let's, should be most web apps. So let's try. You can just hit inspect. And you can see, let's try it. Let's put this smaller first. So you would see a lot, this one. So this one are scripts. Let me put this bigger. So again, for those who can't see, please go to the zoom so that you'll see it better. Oh my God, it's black. So you would see script. It uses JavaScript there. Okay. Because you can use JavaScript for your animation, and also you can use JavaScript to manipulate DOM elements, also to make it dynamic so that when the database changes, it will reflect the changes in the front end. Okay, sure. So lesson 1, based on the book that we're given, so sorry that it's late. So the focus for today is values, types, operator, program structure, create TypeScript and JavaScript. So we'll try to, hello, I'm Clark, I forgot to mention. And agenda, what is programming? We'll go back to the basic very quickly. What is JavaScript? What is TypeScript? And again, let's do a coding side by side and discuss more of the team project and how the course structure and the requirements are, okay? So basically, what is programming? You have a computer, you have a set of instructions, you just tell the computer what to do. Okay, it's as simple as that, but it's hard to really understand once you go to the machine code level and try to understand the binary numbers and what those code translate to. Like, is it looping? Is it going to a next code block? Is it storing a variable? So next, so this is machine code level. It is binary, 1 zeros and 1 zeros. I think you guys already done this in Bash or not. And then JavaScript, on the other hand, is easier for humans to read. So you can say that this is a high-level programming language. Okay. So what is JavaScript? JavaScript is a high-level interpreted scripting language that conforms to ECMAScript specification. High-level meaning it's farther away from the machine, meaning it's more abstraction. It's easier for humans to read, but also you would have more performance or memory problems, meaning if you have a C language, that is better in performance, but it's harder to create your code there. Okay. Scripting language, meaning it doesn't need its own runtime. It uses a special runtime. In this case, it goes to the browser and uses the V8 engine of Chrome. So it conforms to ECMAScript specification. ECMA is European Computer Manufacturers Association. Basically, it's a international organization right now that tries to put a standardization for JavaScript. Okay. So again, going back, what is high-level interpreted scripting language? Easier to use, no compilation, which is bad at the same time because it doesn't show you what your errors before runtime, and it needs a special runtime. Okay. So some examples. Again, we have the C++, C#, Java as your low-level programming language. Your high-level programming language should be JavaScript, Ruby, and Python. So JavaScript also have dynamic typing. It uses a curly bracket syntax, meaning curly bracket is this. Sorry for the other side, you can see. Dynamic typing, prototype-based object orientation, and first-class functions. Wow, too much. Okay. So what is dynamic typing? Basically, it's variables that has no types. So let's say var a, and it doesn't have a type yet. And then you put, let's say, a string, it becomes a string. And if you put a number afterwards, it becomes a number. So it's dynamic, it's changing. Next. Prototype-based object orientation. This one is a bit complicated even for me. So it just means that there's code reuse. It's classless. It doesn't really have a class like in C++ or C#. When you see a class in ES6 standards, it's just a linking of objects. There's no real class. And prototypal inheritance, that's the one I said. Okay. First class functions, basically these are functions that can be stored in a variable. Let's say I have a function declaration and you have a variable. You can assign that function to that variable. And also, you can also pass a function to a function as a parameter, which is also called a callback. You can return from a function. So this is how it looks like 1995. The Netscape Navigator is I think it's the first time that JavaScript had an app in the browser. So this is what I remember, because this is my generation. Okay, moving on. So I'll quickly go over this. So Brenda gave birth to JavaScript 1995. Officially, ECMAScript, again, it's a standardization. ECMAScript 2, 1998, 3, 1999. Ajax and jQuery was formed in 2005. And Mozilla also joined the ECMA organization. ECMAScript 5, 2009. ECMAScript 2015, super confusing. And 2016, it's super confusing actually when I look into it. Too much confusing. So basically there's a table that really answers how they are mapped. So look at this, edition ES1, 1987. But when you come to ES6, its official name is ES 2015 in 2015. ES7, ES 2016. So, my God, it's confusing. But one thing to note about in ES5, you don't have a keyword class. You have to create functions and objects to simulate a class. But come ES6, you have a keyword class, but it just masks it. So underneath the hood, it's still the same. Okay.
So, sorry, JavaScript.
Basically, you have JavaScript as a programming language, and you have ECMAScript as a standardization, so like a police. Like hey, this is what we want. No, again, JavaScript is the language, and someone is trying to maintain a certain standards, and that is ECMAScript. They can be somehow used interchangeably. Yep. So there will be times that you would need to run your JavaScript in a certain target because the browser only supports, let's say, ES 5.1. You can put an ES 7 there. Okay. I hope we don't go deeper into this. So JavaScript everywhere, okay? On the client side, most of us already use JavaScript somehow. The moment that you use your browser, you're using JavaScript, the V8 engine of Chrome on the client side. On the server side, we also have what we call Node.js. Node just stands for server, so it's just server.js. So right now, that's why a lot of people really want JavaScript, because you can do it in the back end and also in the front end. So now we go to TypeScript. At first, why TypeScript? Let's talk about that later. So TypeScript, it's an open source programming language developed by Microsoft. It's a superset of JavaScript. So another thing, it transcompiles to JavaScript. So if you have a .ts file, which is a TypeScript file, it just compiles it and becomes a vanilla JavaScript. When I say vanilla, it's just pure JavaScript. And they always have this tagline, it's a JavaScript that scales. Let's talk more about that later. Quick history, Microsoft started to develop TypeScript 2010. The name of that person is Anders. He also is the lead architect of C#. Okay, so that's why one of the focus was object orientation. Next, first release was 2012. Second release of 1.0 was 2014. 2.0 is 2016. And that's it, and now it's today. I think we're on 3 something or 4. Okay, now we talk about TypeScript is a superset of JavaScript. It means that it is on top of JavaScript, and anything that's, let's say, what is today on JavaScript or the future of JavaScript, it will be supported by TypeScript. Okay, as you can see, ES5 is here, ES6 is here, and TypeScript is here. See that I just changed the JavaScript to ES, so because it's interchangeably. Next is transcompile to JavaScript. If you have a file name called code.ts, you just hit the command tsc space your file name. And now what happened is the tsc will compile that and make it to a JavaScript code. So why do I have TypeScript? Okay, one is to use types to prevent programs from doing invalid things. So in JavaScript, we don't have a way to say, hey, this variable is a string. Hey, this variable is Boolean. Hey, this array should only be strings, things like that. And next is you find your mistakes earlier rather than someone else finding it out later. Because again, with TypeScript, it helps you see your errors at compile time, not runtime, okay? So a scenario, let's say someone is working in a company, created JS code, and this is how my code works, a lot of code. And what if one time he left the company? I want to work for a different company, which happens most of the time. Now, the problem is the new guy who comes in, I don't understand the code base. Because when he sees the code, okay, so what does this parameter need? Does it need a string? Would I need to put an object? So he has to spend more time, which is less productivity, spend more time, understand the code base, and harder to maintain, okay? So JavaScript versus TypeScript. JavaScript is very liberal. TypeScript is strongly typed. It doesn't allow you to, let's say you said this variable is the number, and you would try to put string, it would say error, okay? Easier for beginners because it's super liberal. You can just put anything and multiply whatever. Harder to maintain with the scenario before. It's a scripting language because it's in the browser. TypeScript, it's easier to maintain because it's like your code is already documented. Next is you have the benefit of compilation error, okay? Next is it has object orientation, meaning now you can structure your class and objects how they look like in other programming languages like Java or C#. Okay, so we now move on to the textbook. Go ahead.
So,
Mm-hmm.
both TypeScript and JavaScript is considered like as opposed to HTML.
Mm-hmm.
JavaScript is more similar to Python. TypeScript more similar to Java. All general sense.
Yeah, correct. So it has the structure. And again, the one who created this is for is a C# lead architect. And another thing, what was I saying? JavaScript, that's it. Oh, okay. So I tried to dig deeper on why they really developed TypeScript. So there was a time that they say, oh, we have JavaScript for quite some time now. And they're like, why can't we put object orientation there? And turns out the JavaScript code is already very large, that it's so hard to fix it to have object orientation. So instead, they created a TypeScript for that. Okay. So going back to the textbook, we'll go back again to the basic stuff. So when we talk about values, what are values? So when you put one is a number. Hi is a string. So basically, it has a type associated with it. You invoke the name to create a value. Okay. Operators can act on the values. So let's say you have a value, and an operator plus, and you have a 1, 2 values, and now the operator can work on those 2 values. Okay. Things to note in JavaScript, numbers, it can be as big as you want, but once you go to the 2 to the 53rd power, you would have some precision loss, meaning you won't have the same X number of decimal places in that place, unless you use a different keyword called big int. Next is the strings. You would have double quotes, single quotes, and ticks. So who knows what's the use case for this one? Okay?
I have a gut feeling.
Okay, so basically you would use double quotes when, let's say, you have a string that has double quotes inside it. So no, you don't use it because you need to escape it. I'll show you later. Okay, in single quotes, you would use that if you have double quotes inside your string, so you don't have to escape double quotes. In ticks, you would rather use that if you want, let's say you have a variable and you want that variable to be used inside the string. Okay, functions, we'll talk about this later. Later modules. Okay, operators, basically we have the plus, minus, times, divide. We have the modulus operator, which gives you the remainder. You have the infinity. You don't really use this. You have not a number when it is not a number. So types of operators, you would have unary and binary. When you say unary, it only needs 1 value. When you say binary, it needs 2 values. So let's talk about first with binary. So when you do plus, minus, times, divide, you need at least 2 values, right? And if you also need to compare them, you would need 2 values. Is A equals to 10? Is A less than 10? Is A greater than 10? Unary, on the other hand, you just need 1 operator. So when you use, let's say, this API called typeof, when you put typeof and then, let's say, a number, it would check if it's a number or not. It would say number. If it's a string, it would say it's a string. If it's an object, it would say it's an object. Next, program structure. So in the basic world of programming language, we do have what we call expression and statements. So to drill down the concept, expression just means that the value is written literally. Again, when I said 1, 2, hi, hello. And statement is just basically an expression plus the semicolon. So that's when you see the code line per line. And if it ends with a semicolon, that's an expression. Okay? Program is just a list of statements. Okay? Bindings, you can catch and hold the values. You also assign values to a variable. You bind a value to a variable. I would like to bind number 2 to the variable A. Okay. Binding name. Okay, so some names that are allowed in JavaScript and not allowed in JavaScript. You can have basically letters, $, underscore as the first of your letter in your variables, but you can't have punctuations and special characters. And also you can use let and var. Okay. A while ago we used CONSOLE.LOG. Basically it's a function that takes arguments and writes out the values. It outputs the values. And going back, this is very, very helpful when you go to full stack and you like to debug and, hey, what does this variable do? Hey, what does this function return? This is what you use, put that inside your code, save, compile, check your browser, and it tells you what's wrong. Okay, next is return values. So basically what you get, a value that you get. So function can produce values. How? So let's say you have a math.max, it's a function, and you put 2 and 4, you get a 4, which is it returns the value of 4. On the other hand, look at console.log. When that console.log sees the 4, it doesn't really return the value, it outputs the value. Okay, we'll be also talking about control flow statements, but I'll just quickly run this through because you guys know this already. If statement, you have a condition, and then if it's false, it just goes here and ends. If it's true, it goes to the other conditional code or code block and continues. And then next, wow, green is not good. You would have if, else if, and switch. You kind of already know this with bash, so moving ahead. Loops, again, you go to the condition first and evaluate that. If it's true, you keep going back to the loop and exit this if the condition is false. For loops, basically you have statement 1, statement 2, statement 3, and the code block to be executed. You start with the keyword for, and you open up with the parentheses, and the code block should be in braces. Tell me if I'm going too fast, but don't worry because I'm gonna go back to coding next. Again, for loops, the syntax for JavaScript is you first need to have the statement 1, which is your initialization, correct? You execute it one time, you set a variable as well. The next statement is your condition. You define your condition, and if it's satisfied, it will run the code block. Next is your loop counter. Okay, so loop counter basically is executed every time the code block is executed. So this must run first, and then when it reaches this one, it goes increment. Break, basically when you put the break keyword, and if it reaches there, it just ends your loop. Continue, if it sees the continue keyword, it just goes back to the loop. And comment. You need a / or / asterisk and asterisk /. You would use this for single lines, and you would use this for multiple lines. And let's see, we'll go to coding again, but some things to note about before we go to code. One is with JavaScript, you can get crazy with different types of data and operators. And you would have this type coercion. It looks cool, it looks magic, but you don't really want that. For TypeScript, it's like, it's the mom you never had. And it helps you be, it basically fixes your stuff before you go out there. Okay, so JavaScript, you have runtime kaboom, and TypeScript, you have compile time kaboom. Okay, let's try to quickly go over this in live coding. Let's see. So first, values. What are values? Again, this is 1. 1 is a number. This is a string. This is Boolean. Okay, so these are values, and when we want to assign or bind them to somewhere, because it just goes away, right? So now you create a variable. So let's say you do var. It's a keyword to declare a variable. Now you put a name, say b1. And now with that, you assign the value of 1 to b. So when we call that, console.log 1, and then run that. I run it using node, and you see 1 down there. Okay, same goes with string. Actually, I should put the variable there a while ago. There you go. Okay, so next thing is, let's do operators. Say 1 plus, let's do the console.log. 1 plus 1. What is the output? 2. Okay, how about this? 1 plus the string of 1. 11. Wow. So this is the magic that TypeScript has. It's called type coercion. It means it forces the other type to be something else so that they can be the same. So let's say when the program sees, oh, I see a 1, that's a number. Oh, I see another 1, that's a string. But because of the plus operator, the plus operator not only does an addition, it also you can use it in strings to concatenate stuff, right? In Bash. Oh, go ahead. Yeah. So because again, you can't really add a number to a string, right? That's 1. So 2, because you can also use this for strings. Now it says, oh, I can just make you to a string. Add it. So why not change the 1? That one, we don't know. Yeah, so you can also check its type to be sure. This is also helpful when you're starting off with any programming language. Find this same type of keyword, type of, and now it says it's a string. Yep. Mm-hmm. What do you use the console log? Yeah. So, so basically console.log, you can, in other programming language, it's like their print. That's it. Yeah. And again, it's helpful because when you put console.log and it's in the browser, you would see that in the browser's console instead. The developer tools. Yep. Mm-hmm. And then let's see, what else do we have for? Okay, so how about this? What do we get when we multiply 1 and times a string of 1? Either an error or 1. It's a 1. So look, if I put 4, why? Multiplication isn't the string method. Yes. So instead of coercing the number to a string, it's coercing the string. Yes, that's it. And then what else do I have for values? So you can also put array. An array, you can just put a square bracket, and let's say Final Fantasy, say 7. Put that there. not a number. Okay. Let's go back to this one a while ago. And if we just want to confirm the type, let's just do this. It becomes a number. And it is 4. Yep. Let's go back to Final Fantasy. Copy that. So, not a number. The type is not a number. It's basically that's it. Boolean. So for Boolean, you just need to have the keyword true in lowercase or false in lowercase. So true. Let's try it. And you can also evaluate it to true, be true, false, be false. Okay. I'll give you, now we're moving on to comparisons. Okay. Go ahead, go ahead. Yeah, I'm going there. Yeah. So I'm going back to the number again. So with type coercion, what is this? Is this true or false? It's
type of it is true.
True. Okay. You can also, there's 2 ways you can do this so that it becomes more strict. One is you make it triple equals, and now it will become false. Okay. It just says don't convert. Another way to do it, which is a best practice, let's say you have only 2 equal signs. You use this use strict. And now, still true. No, it should be false. Okay. I used it incorrectly. Use strict directed. Yeah, this one should be false. Okay. I'll move on to this next time. Let's see. We've done some, let's go for some comparison as well. So let's see. Is this equal? Is A, capital A greater, equals to small case a? False. Is it greater than though? If you remember your Bash programming language, you had this lowercase, uppercase, and you kind of see the ASCII values there. So A, the capital letters have bigger values or smaller values. Let's see. False. Like smaller values because they go first. They go first. There you go. So let's see more. What types do we need? Subtract, divide. Go ahead. Yeah, sure. Okay, so basically, if you want to avoid type coercion, you would use the triple equals. Okay. Yeah, so if it's a string and a number, if you use triple equals, it will try to evaluate those. If it's just double equal, it will try to change one of them and see if they're the same. Hmm? Correct. Correct. I may have missed that. So again, when you assign variables, you just use 1 equal sign. If you want to compare, you use 2 equal signs. And if you want to be strict about your comparison, you use 3 equal signs. Okay. Next. And also try to do some object calling. Let's say object that foo. Okay. Let's output that. So this is how we define objects. We have braces. Okay. So now I'm calling objects method foo. What would be the output? Undefined, because you haven't created the method foo yet. So now you're seeing, hey, it's JavaScript and it lets you do stuff, right? Let's see. Full object. You can also create a function. Function, let's say divide by 2. You have a num. Say you return the num divided by 2. Close that in semicolons. Let's put that. Divide by 2. T4. Oops. Okay. It's 2, right? But if you supply this with a string, it runs. Okay, so let's say a real string. Now you have this not a number, which you don't really want. Okay, so now we're gonna move on with TypeScript. With TypeScript, you can just easily create the same file and change it to .ts. Okay, let's do this side by side now. Right. Okay, zoom out a bit, zoom out a bit. Okay, CONSOLE.LOG. So I run tsc demo.ts, compiles and becomes a JavaScript file. And you would see on the other side, it's the same, right? If I want to run the JavaScript file, I just do node, and there you go. Okay, now let's go with variables. So let's use the let again. It's kind of the same as var, but var is global. Let is locked into a scope. Okay, let's do it in JavaScript first. Okay, let a equals hi. And then console.log we get hi. Okay, put that here. Should be the same. Let's just do a shortcut. Should do this and then watch. So that it does automatic compilation for me whenever I save. So when I now use one of the core features of TypeScript is putting types, right? So I can put this one, string, and that should be okay. But if I, let's say, reassign it to the number 1 and save it, it says here, even here, type 1 is not assignable to type string. Again, if you remember, JavaScript didn't give us this nice information. Okay. Then what else? Let's see. Okay, I remember. Adding stuff. So let's say we not do this. Let's do 1 times the string of 1. It doesn't let us as well. The right-hand side of an arithmetic operation must be of type any, number, begin, big int, or enum type. Okay. And also do this with numbers. 1, 2, 3. And then let's say I want to assign a string. It says type hi is not assignable to type number. Again, hi is a string. That's why it doesn't let you. Okay. Let's go back with the string, because I missed something else a while ago. Using double quotes, single quotes, and ticks. Okay. Let's first use double quotes. Okay. Let's say I have the word I don't know. That's fine. But if I put single quotes while using a single quote inside, You see what happens there? It thinks that I don't is the string, and all of those are typos. They think it's that. So the another way that if you really want to do single quotes, use single quotes and have single quotes inside of it, is you put the backslash operator to escape that. Okay, same goes with double quotes. Say you have this, you escape that with the backslash. Okay, let's now use the backticks. So let's say we have a number, and let's call it age. What's your age? 42. Okay. Let's say, you can say prayers age is, and then you put the $sign, you open it with a brace, and close it with a brace, and put age. And there you go. And as you can see on the right-hand side in the JavaScript, doesn't really need to do the backticks, the pure vanilla JavaScript because of type coercion. And if I run this, I should see praise age is 42. Okay, let's see what else. And let me know if you want to mess the code. We can just write any code there and try stuff out. Let's see. Okay. So I want to stop here first because I want to go through the course content quickly and what we're going to do in this course, what are the requirements. And hopefully you guys can set up the environment as soon as possible. Also, let me know what else do you want to know right now? What do you want to test? Okay, I'll give you an example. So let's say you have a if statement here. Say, be here. Okay, let be. So here's an example. So I have a variable named A, and then its type is number, and assign it to number. Don't focus on this now. I just use it for the each block. If 1 is equals to 1, create a variable b equals to 1. But now because this is the brace, this is a brace, it's in a scope. Yep, it's inside the scope, and you want to access it outside the scope. You cannot find it. But if you put var, is used before being assigned. Something like this. Yep. But best practice, we really try to avoid using var. Because problem is if you have a big code base and now let's say, oh, I thought of a variable, let's use the variable A. And you didn't know in the other code base there's a var A. You would end up changing and breaking the other code. Unless when, let's say, you put it inside of a scope. Again, if you put var inside of the scope, it can still be changed because it's global.
So if you instead of the time on line 2, if you said let there instead, would it like transfer to inside that statement? So
this one?
Yeah. So no. declare it as a let. Line 2.
Okay.
Yeah. Okay.
Now the scope is in the scope of let is the filing.
Okay.
Okay.
But if you declare it inside the if statement, then what?
Yep.
Okay. Okay. So it's kind of like.
Yep. Anything else?
Declare
But best practice is just let all the time.
Yeah, I got that.
Okay, I want to move on. Oh, go ahead. Oh, const is something, sometimes you want a value and you don't want it to change already. Okay, let's say the number of pi. You don't want that to be changing. Yeah, use the const. Okay. Okie dokie. Okay, let's talk about the course schedule because I don't have this course shell. But I do have the other shell. Let's see that. Like this one. So again, you still have the muddiest point concept test later. Hands-on practice. We'll be focusing on you guys going through TypeScript. All of this will be in TypeScript. But again, when you compile it, it's also in JavaScript. It becomes JavaScript. Okay, so that one, you guys know how to just walk through it. Programming labs, we're still gonna use CONSOLE.LOG. This time around, it's different. It's all JavaScript. So hopefully one of my goals for you guys is if you have time, I really want you to finish the JavaScript certification so you get something out of it. I did try to check the module again. It would take time, but you can finish it. So this is the section for that. Let's go there. So you have this one. So I think also send the PDF file in the email so you guys can keep track even though we don't have the course shell yet. So one thing to note about that, this basic data structure could be still easy because this is just arrays and I think objects. It can get a bit tricky with algorithm scripting, basically doing some basic algorithms. Then next would be the intermediate algorithm scripting, still doable. Okay. Yes. So this is the JavaScript algorithms and data structure certification. And lastly, we do have the 5 projects. And again, to lessen the load, we'd like you to do the team project with this one. So all of you guys, let's say you're in a team of 3, you guys collaborate and do this. And one of the things I like you to do daily is, right now, even though you don't know the syntax of JavaScript, but you can pseudocode, right? So we pseudocode until you get that, you learn the syntax for that. And then things to note for this one, for those who already passed the Linux class, you are required to do this, okay? For those who haven't, it's optional. You can still do the Linux class report, or you can move to this.
For presentation.
Yeah, presentation, correct. Yeah. No, that's a problem. Even I don't have access. This is not the live show that I'm showing. But hopefully today you would have that. But I already sent the email because you can start working with the JavaScript. That's a lot. The free code camp, that's a lot. But it really helps you. And hopefully if you have questions, we can tackle it in the class, or we can also utilize the Apprenti TA Center. I'll try to respond more as I'm your instructor for this class. Next is, let's see. Oops. So I think we covered the programming labs, the team project. Oh, team project. So the aside from submitting it in the free code camp as an extra challenge, we want you to build the TypeScript version of that. That should not be very hard. So there's two ways to tackle it. If you're feeling confident, build a TypeScript program, compile, and then submit to free code camp. Or you can do it the other way around. Build the JavaScript code, and if it's good, submit it to free code camp, and then create the TypeScript version of it. Because one thing that may be hard for you is, at least when you put JavaScript right away, you can see in free code camp, hey, it's wrong. But if you're doing it in TypeScript, you copy paste again, copy paste to check. Because you keep compiling the TypeScript and then pasting it again. Okay, what else? The course schedule I've sent you, but let's go over that quickly and set the expectations. Let's see. So we're done with day one, almost done. Done for me, I guess. Day two, we'll talk about JSON objects, basically JavaScript object notation. It's just a way JavaScript does create an object. Arrays, just a recap with you guys, doing some functions. Next is functional programming. Next would be object-oriented programming. And next week, we'll go with bugs, error, regular expression, TypeScript. Regular expressions is really helpful if you have like input data validation type of problems. You would encounter it also in lead code or whatever. Day 7, please don't miss this because this is a very important topic. What is asynchronous programming? Because JavaScript can be very convoluted in how it works in the browser. And 8, 9, 10 will move to something different because it's required in your program to have some data structures and algorithms. So day 8, I'll be discussing the basics of algorithms, time complexity, space complexity, and introduce you to basic searching and sorting algorithms. Day 9, hash tables, stacks, and queues, which are data structures. And day 10 is also data structures, linked lists, and binary trees. The expectation for this is you guys to be familiar with it so you get to use it. Because one thing that's good with data structures, once you know it, that's the same way to implement it all the time. There's only one way to implement a queue. I mean, there's different ways to implement a queue, but if you want to be efficient about it, there's one way to do it all the time. Okay. Searching and sorting, we'll discuss about linear search, binary search, merge sort, things like that. I don't like the 10 and 9 to be heavy so much so that you guys can finish more of the free code camp and also, again, study more with the Linux class. Okay. Let's see. Syllabus. Okay. Any more questions though that pops into your mind? If not, we'll be doing the concept test. And again, if you have questions, please post in Apprentice TA Center and I'll try to respond. Okay. Concept test. Huh? Yeah. Oh, break first? Is it break first before concept test? Okay, break time. I didn't know, sorry. Go break time, thank you.